Okay, we're here now to put it all together. After this, you should be able to graph any sine or cosine graph that ever existed. Congratulations to you for getting this far. Um, so what we're going to do is we're going to see sine and cosine functions written in this form. And we've seen it so far in the other videos, but we haven't really discussed it as much. Each part of the equation has its own variable to recognize it. And so A is the amplitude. B helps you find the period. Remember, B is whatever number is in front of x. It's the coefficient of x, and we use that. We divide 2 pi by b. That gives us the period of our function, and we use that to also divide all of our x's by that b as well, so that we know where each of our x coordinates went. C helps us find the phase shift. Remember that subtraction would mean we phase shifted to the right. Addition means we phase shifted to the left. And actually how far the phase shift is, we take C and divide it by B. So these are problems we've done before. You can look at previous videos if you need to, but the idea is we're putting some letters behind each of the pieces of the equation now. And finally, D tells you how far up or down the function has moved. It's your vertical shift. So the steps for graphing a sine or cosine equation are here. I'm not going to read them to you. You can read them yourself, but we will go through the steps together. There should not be two step 5s. There's step 6. Let me fix it over here as well. Hopefully you guys are enjoying your day. I am as well. Okay. All right. So, okay. So that was step 6. All right. So the first thing we're doing is an example down here. We have a vertical shift of 3 down, so I'll put a vertical shift of -3 or 3 down. We have an amplitude of 2, that's the A. We have a phase shift of 0. There is nothing being subtracted in the parentheses with the x. The period will be 2 pi divided by b, and in this situation b is 2 again. And so we get a period of pi. From there, we'll go ahead and make our charts. So first we'll start with what is this? A sine chart. Here's our sine chart. We'll go ahead and take care of our amplitude. Amplitude has to come next. I should have written that in that order up here, but amplitude is the next step. So we're going to take all of our y's and double them. So that leaves that as a 0, but that becomes 2. That becomes -2. And next we'll deal with our vertical shift, which sends everything 3 down. So we'll take 3 away from all of our y's, because that's how we move something 3 down. So -3, -1, -3, -5, and -3. So we've taken care of vertical shift and amplitude. We have no phase shift, so now all we've got to worry about is period. And the period change is best fixed by dividing all of our x's by b as well. And so we'll start again with our chart. Push the rest of it down just in case we need some more space. So this will be, I already took care of the 2 and the -3. Now we're going to change it to 2 times the sine of 2x minus 3. And our y's are set in stone. We're good with -3. And I'll stop there. Our x's, so we're going to take 0, divide it by the b, which was 2. So we still get 0. Now we'll take pi over 2, divide it by 2. That is, after some fraction division, you'll find pi over 4. That leaves us with a -1 there. Then we have pi divided by 2, which is just pi over 2, so we don't need to worry about that. Then we've got 3 pi over 2 divided by 2, and after some fraction division, you'll find that's 3 pi over 4. And finally, we've got 2 pi divided by 2 is just pi, and so we're left with pi at -3. So with these x coordinates and y coordinates, we can finish our graph. 0 starts at -3. Pi over 4 goes up to -1. Pi over 2 is at -3 again. 3 pi over 4 is down at -5. And then pi is at -3. Here's our function and here's our points, and on to the next one. Okay, this time we have a vertical shift of 1, amplitude of 1, so don't have to worry about that. The phase shift, remember the phase shift is c divided by b. In this situation, c is pi, b is 1/2. When you do pi divided by 1/2, you actually get, I should try to draw a line here to separate that, you actually get 2 pi. So this phase shift is 2 pi, and because that was subtraction up there, it's 2 pi to the right. And finally our period is 2 pi divided by b, and b in our problem here is 1/2, so our period is going to actually be 4 pi. Alright, and so let's get our cosine chart started. And since our amplitude is 1, we don't have to multiply any of our y values by 1, so all we have to do is move them all up by 1. So we are at 2 for y there, 1, 0, 1, 2. So those are our values for y. Now we've got to deal with both a phase shift and a period change. So to deal with the period change, let's go ahead and divide all of our period changes have to come before phase shifts. Again, I wish I hadn't set it up this way, and I'll change it for the next problem, but amplitudes should come before vertical shifts, and period changes should come before phase shifts. So we'll have to fix that. But right now we have to divide all of our x values by b. That's the way we adjust for our period change. So we're going to take all of our x values and divide them by b. Alright, so we'll take 0 pi and divide it by 1/2. We still get 0 pi. So 0 pi 2. And then we've got pi over 2 divided by 1/2. And you'll actually find out that is pi. And that's 1 for our y. Then we've got pi divided by 1/2. If you do some fraction division, you'll find out that's 2 pi, and I believe that went down to 0. Then we've got 3 pi over 2 divided by 1/2. That ends up equaling 3 pi. That's back to 1. And then lastly, we've got 2 pi divided by 1/2. That equals 4 pi. And our y coordinate there was 2. So that's taking care of the period change. We've moved all of our, we've divided all of our x's by 1/2, and you can see that our period now goes from 0 pi to 4 pi, and that's good because we knew our period was 4 pi. Now the last thing we need to do is move everything 2 pi to the right because our phase shift was 2 pi. And so we need to add 2 pi to all of our x's so we can move them all to the right. And I'm going to take a bit of a shortcut here. I'm not going to write a new chart. I'm just going to go ahead and say that was 1/2 x minus pi plus 1. And so all we have to do is add 2 pi to all of our x's. So that becomes 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So there we go. So 2 pi 2 is where we're going to get started. And again, you can kind of just do this break in the graph and say, here we go. Here's 2 pi. 2 pi 2 is our first coordinate. And then we've got 3 pi 1 and 4 pi 0, 5 pi 1, and 6 pi 2. Those are the coordinates for our cosine graph. So coming down here, try to have it nice and smooth. And so here are our 5 coordinates on our beautiful cosine graph. Last one here. Alright, we have an amplitude of 2, a vertical shift of down 3. We've got a period that would be 2 pi divided by 2, which is just pi, so our period is pi on this one. And a phase shift that is pi over 2 divided by 2, so that's like 2 over 1. This is going to be pi over 4, and it is going to go to the right. So let's start, it's a cosine graph, so let's start with our cosine points. Here are our cosine points. let's go ahead and take care of our amplitude and vertical shift really quickly. So our amplitude of 2 will double all of our x's. So 2, negative 2, and 2. Move everything down 3. So that becomes negative 1, negative 3, negative 5, negative 3, negative 1. So we've got our vertical shift and our amplitude taken care of. Now for our period is supposed to be pi, which means that came from having a b of 2. Remember, our b is equal to 2, and so we've got to divide all of our x-coordinates by b now. So that's our next step. I'm going to push everything else down. Go ahead and take all of our x's and divide by b. So we'll divide 0 by 2, still 0 for our x, 0 pi, and our y is still negative 1. We'll divide pi over 2 by 2, and we get pi over 4, and a y of negative 3. I'm running out of space here. Then we've got pi divided by 2, which is fine, just left as is, and that one was negative 5. Then we've got 3 pi over 2 divided by 2. That leads to 3 pi over 4, and that's negative 3. And lastly, we've got 2 pi divided by 2, which is just pi. And that was good because our period was pi, so now we start at 0, we end at pi, and that would be what we do if we didn't have this darn phase shift. And so remember, the phase shift is pi over 4 to the right. And so we're going to have to add pi over 4 to all of our x's now. That'll be tricky, but we can do this. Okay, so we're moving everything pi over 4 to the right, so we got to add pi over 4 to all of these. So we get pi over 4 as our first x, and a negative 1 for our y. Then we got to add pi over 4 plus pi over 4. That's 2 pi over 4, which reduces to pi over 2. Then we've got pi over 2 plus pi over 4. We could use a common denominator there, so that's 2 pi fourths. That's 3 pi over 4. And then 3 pi over 4 plus pi over 4, because we're going to the right, pi over 4 gives us 4 pi over 4. That's equal to pi. So fill in our y values on those. And then finally, we have pi plus pi over 4. Common denominator, make that 4 pi over 4. We get, we get 5 pi over 4 at negative 1. So these are our 5 coordinates. Let's get them on the graph quickly before I run out of time. So we were left with pi over 4 at negative 1, pi over 2 was negative 3, 3 pi over 4 was negative 5, pi was negative 3, and 5 pi over 4 was back to negative 1. So we had our cosine graph looking like this, and here's our 5 points. Pi over 4, negative 1, pi over 2, negative 3, 3 pi over 4, negative 5. Move those over a little bit. Pi, negative 3, and 5 pi over 4, negative 1. Alright, so that's putting it all together. Now we can graph a function that has every single change you can imagine.